Welcome to solverfy.
So this question, we want to prove an equivalency between these three statements. So x is rational, x over 2 is rational, and 3x plus 1 is rational. So the question, or the textbook, wants you to solve if and only if condition between these two, and if and only if condition between these two as well. So once again, we'll do something a bit different. So if this is proposition 1 and proposition 2 and proposition 3, what we'll do is we'll prove a circular chain of these propositions. So proposition 1 implies proposition 2, which implies proposition 3, which implies proposition 1. So this then shows an equivalency between all these three things, is because if we want to show an equivalency between P1 and P3, so P1 and P3, what we'll do is, because we have an equivalency between P1 and P2, we'll have an equivalency between P2 and P3. It follows that P1 is therefore equivalent to P3. And you can do the same thing for the other stuffs. So we'll just start this proof then. So to prove P1 implies P2, so if x is rational, then we can write this as a over b, where a is some integer and b is an integer but not 0. So then x divided by 2 is equal to a over b times by 1 over 2. So this is just a over 2b. So since this is an integer, this is also an integer not equal to 0. We have that x plus 2 is rational. So we've just proven P2. So we start from P1 and we prove P2. So to prove P2 implies P3, we start from proposition 2. So if x over 2 is rational, then we can write x over 2 as being a over b, given the same condition. So we can multiply the 2 across. So x is equal to 2a over b. Now 3x minus by 1 is then going to be equal to 3 times by 2a over b minus 1. 3 times 2 gives you 6. A over b minus by 1. Then this can be written as 6a minus by b over b. So we can write this as c over b, where c is equal to 6a minus b, which is some integer. So therefore, this is a rational number because it's some integer divided by some integer that's not equal to 0. So we've just proven proposition 3. Now for the last one, proposition 3 implies proposition 1. So if 3x minus 1 is rational, then we can write 3x minus by 1 as being a over b, where a is an integer, b is an integer not equal to 0. So moving the 1 across, we have 3x is equal to a over b plus by 1. So this is just a plus by b over b. Dividing 3, we have x is equal to a plus by b over 3b. So this is some integer divided by an integer that's not equal to 0. So therefore x is a rational number as well. So hence we've just proven P1. So we've proven then proposition 1 implies proposition 2. So we've proven this part of the chain. We've proven proposition 2 is equal to proposition 3. So we've proven this part. And we've also proven the last part, that proposition 3 implies proposition 1. So since we have this circular chain of proofs, all of these three statements are equivalent.